Hi everyone, this is Dinesh, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, and today in this video we are going to see the case study, that means the comparison between the conventional and unconventional machining process and what are the uses of unconventional machining process over the conventional machining process. Okay, so first we have to know what a conventional and unconventional machining process is. Okay, the term machining defined as removing of material, right, which we everyone know that whenever a word machining is implemented in a process, that means it is subtracting the material, okay, or we can say it as removing the material from the workpiece. That's what machining is. So in that there are two types, one is conventional and another one is unconventional. The conventional machining process, for example, if we take lathe machine is a conventional machining process. Okay, so where we have workpiece and then we have a tool. The tool remove the excess material from the workpiece by direct contact. Okay, so the tool will touch the workpiece and then the process has been done. Okay, this is what conventional machining process is. But in normal lathe we are in our labs and everywhere we use cast iron as a workpiece, right? And for tool we use as edges, eye steel as a tool, the material which I am talking about, and then the carbide tool is also be used to remove the materials. Okay, this is what conventional machining process is when there is a direct touch between the tool and the workpiece in order to remove the material. Okay, so the main drawback in this is there will be a breakage in tool, and due to the vibration, due to direct contact, there will be more heat will be produced and which will damage the tool or the workpiece, and due to the vibration it will affect the smoothness of the workpiece. So these are all the some of the disadvantages of conventional machining process. In the other hand, unconventional machining process is a process where the machining is done without touching the workpiece and the tool. Okay, when there is a slight gap between the machining and the workpiece and the tool is what we call it as unconventional machining process. Okay, for example, if we take EDM, okay, electric discharge machining. Okay, in the electric discharge machining, the workpiece is kept inside a dielectric fluid. Okay, and then the electrode will be placed inside the dielectric fluid with a certain gap between the workpiece and the electrode. Okay, when the process is done, the electrode will give a spark, okay, which have a very high voltage of electricity that will use that heat will make the workpiece to melt and evaporate. Okay, so this is what how EDM works. Okay, so in the EDM, just for example, the spark, for example, if you take an IC engine, okay, first the suction will be there and then compression. After the compression stroke, the spark plug will ignite a certain amount of spark which helps to produce the power stroke, right? So the same process, the same spark will is used in EDM in the electric discharge machining for machining the workpiece. Okay, so when it's compared to the even though there is water jet machining, electric beam machining, and electrochemical machining, so these are all the different types of unconventional machining where we use nowadays. But we use the unconventional machining process to machine the high strength materials like aluminum, tungsten, okay, titanium. So these are if we take for example, take titanium has a very high weight to strength ratio. Okay, so it's hard to machine by conventional method, so we are going for unconventional machining process. So which it have a very huge applications, like mostly it was used in aerospace industries, which we know that even in the landing gears we use titanium. Even in the satellite, most of the areas are done with the help of titanium alloys. The reason is the titanium has high weight to strength.